Hello, in this video we are going to cover 5.7, which is systems of linear inequalities. And first thing that we need to discuss are some definitions. So a system of linear inequalities is a set of two or more linear inequalities in the same variables, and you can see two below. And then a solution is a solution to a system of linear inequalities is an ordered pair that is a solution to each inequality, so it has to work for both. So we did this when we were doing systems of linear equations, where we plugged in an ordered pair to see if it worked for each inequality. So the ordered pairs that we need to use are, for example, one are 3, 5. And then the second one we'll do is -2, 0. Okay. So we just need to plug them in. We'll start with 3, 5. So go ahead and pause the video, plug in, and see if your answers match mine. And do the same thing for B, actually, because this is pretty straightforward. That's true. Okay, so A is a solution and B is not. We can check the second inequality if we want. But it's not really necessary because it doesn't work for the first equation. So I checked it in the first inequality and it didn't work. So this one's no. It needs to work for both. Okay. So a graph of a system of linear inequalities is the graph of all the solutions of the system. So it's real similar to what we did in 5, 6, except we're basically going to have two graphs on top of each other. So we're going to graph each inequality in the same coordinate plane, and then we'll find the intersection of basically the shaded areas, and that is going to be our solution set. I'm not going to have you erase or anything, so when you graph your first graph, you might want to graph pretty lightly, and then we'll shade the overlap in darker. So first example, graph the system of linear inequalities. I'm going to use two colors. I'll do the first one in black. So just like with regular inequalities, you want to graph the boundary line first. So for this one, we know that it's going to be a solid line. And let's start by graphing y equals 3. So if we graph y equals 3, that's a horizontal line. And test a point, I'm going to test 0. So 0 is less than or equal to, or is 0 less than or equal to 3? And yes, that is true. So that means that I'm going to be shading, and I'm going to use a highlighter actually. Okay. So that means that I'm shading the bottom here. Then the next inequality, which I will do in red, this is going to be dashed. And we need to graph the boundary line y equals x plus 2. And so that's a y-intercept of 2 and a slope of 1 over 1. So dashed line. Edge to edge. And so what you want to do is you kind of want to ignore what you have, all the black shaded part and the black line, and just focus on the red. So the red line, dashed line, is dividing this graph into two portions. And so I'm going to test, because I always like to test, 0, 0. And I'm going to see if that is a solution to my inequality. So if I plug in 0, 0, 0, we're checking, is that less than 0 plus 2? 0 is not, or sorry, greater than, said the wrong thing. So we're checking if 0 is greater than 2, and it is not, so we are not shading where 0, 0 is. We are shading above the line. Okay. All right, and then you can see now where the overlap is. The overlap is where I have my red highlighter and my black highlighter. So I'm going to take, I don't know, maybe I'll use blue. And I'm just going to emphasize that area, which is this right here. Okay. Now, any ordered pair that we plug in this blue area is going to work for both inequalities. So this is where my solution set is. Okay. Let's graph these. So first one I'll do in red. This one's going to be dashed. And I'm going to get y by itself. So that's going to be, so subtract 2x. It's going to be y is less than negative 2x minus 1. So that boundary line, is y equals negative 2x minus 1. So negative 1 down 2 and to the right 1. Do a few points and dashed. And super important that your line extends your entire graph. So 0, 0 is the point I'm going to test. And if I plug that in, 0 is less than negative 2 times 0 minus 1. So 0 less than negative 1, that is not true. So that means that I'm shading the opposite side. Second graph I'll do in blue. So again, this is going to be dashed. And subtract 2x from both sides. We get y is greater than negative 2x plus 3. So positive 3. And we have a slope. Negative 2 over 1. Dashed again. And we can see that these boundary lines, one's a little messy, but we can see that these boundary lines are parallel to each other. So then let's test. So I'll test 0, 0. So remember, you want to ignore the red line and the red shaded region completely. Just pretend like only that blue line is there. Let's test 0, 0. So 0 is greater than 3, which is not true. So that means that I'm shading, so my test point is right here, so that means I'm shading the opposite side. And what we have here is no solution because there's no overlap. And that's actually all we're going to get to today. So you can go ahead and start your homework. Let me know if you have any questions.